Good day everyone, I'm Sit Kwang Min from Section 2 UTHM of my programming subject. My programming subject is BDA24202, and today I'm going to present about my final individual project which is programming C++. For the introduction, what is a C program? C program is a general purpose programming language, and I'm going to use this C program to solve the problem related to solid mechanics of material science. I have chosen the title of solid mechanics, which is also related to deflection of beams from my solid mechanics too. For the problem statement, as we can see from here, which is the graph, is a triangular distribution beam. So I would like to use this graph to calculate for the maximum deflection occurred and what is the slope at that particular point, which we can, from our knowledge, we know that the maximum deflection occurred at the point where its slope is equal to 0. For the objective of this program, of this project, is to develop a program that can be used to determine the deflection at one point, and is to apply the knowledge of C program that we learned for the whole semester, and to determine the difference when compared with programming answer and the theoretical answer, which by our own calculation. To complete this project, we are going to use two methods, which is flowchart and also the C program. So I'm now to explain about my flowchart. Is here, as we can see, is from start. From start, then we define that the x is equal to 0 and the w is equal to 50. The e is equal to 1, the I is equal to 1. So I would like to use the printf, so it will display that please enter the length of the beam, that the length of the beam is defined by the user. After that, we have include few formula, that is the equation from the double integration of solid mechanics 2 to calculate for the deflection and also the slope. In here, we use the if-else condition, that if x is smaller than length over 2, we can know that is to use the formula of 1 over ei bracket, which is times negative p plus q minus r, which we have defined up there. And if it's not smaller than length over 2, we are going to calculate the deflection by using the formula 1 over ei bracket minus s plus t minus u, which also defined up there. So after the calculation, it's going to display the deflection. So after from the deflection that displayed, we can know that at which point is the maximum deflection. After that, since we use the do-while condition also in this program, so while x is smaller or equal to L, the program will continue with the condition of x plus plus, with the increment of x plus plus. After that, if it is bigger than length, the whole program will stop. And for another flowchart that I have made, which is to determine the slope of the particular point. So we are also define the equation from here. So after the calculation is to display the slope at that particular point, and the program will end like this. Now we take a look about the C program that I have created, which is the include stdio.h, include the cornell.h, and to include the max.h, which involve the max calculation, so we have to include this type of things. And the integer main bracket, which is the standard code. Now we define that we have few floats and also few integers, where we define the x is equal to 0, w is equal to 50, e, which is the Young modulus, and I, which is the inertia. Then the length of the beam is defined by user. So after doing this calculation, and here, which is the if-else condition occurred that I have explained in the flowchart just now. So following this code, the x will be increased by this code, which is x plus plus, which is equal also to x is equal to x plus 1. So the whole loop will re-continue until will run until the x is smaller or equal to L. When it is bigger to L, the whole program will stop. Now I'm going to show about the results from my program. Here, the length of the beam is defined by user, which is 10 that I have inserted. The deflection occurred at each point is calculated. So as we can see, the deflection occurred at x is equal to 5 is the maximum, which is 2343.75. So I have here is defined that the maximum deflection occurs when x is equal to 5, and the slope of at that point, which is length over 2, from our general knowledge of solid mechanics also, the slope at that point is equal to 0. That's the end of my presentation, and thank you for watching.